2022. In today's expert talk, which is our first expert talk also, we are going to talk about the life of a data scientist. What is the day-to-day work of the data scientist? What is the career roadmap of the data scientist? What kind of skills you need as a data scientist? What kind of technical knowledge you need as a data scientist? And who is better than a seasoned data scientist to talk about this? So for tonight's event, we have our guest, Mr. Ankush Shukla, who is right now the data scientist as a quick delivery company, Blinkit. And he will guide us throughout this event that how to become a data scientist, what are the requirements of the data scientist, what is the job of data scientist, and how essential data scientists play a role in a company. So over to you, sir. So my first question is very simple. Like, what is the job of data scientist? What you do, like at 9 a.m. you are entering in the office. Now, what's the job of a data scientist?
Yeah, interesting question. So let me quote a person, and in fact, I had him on my slide. The person is called Clive Humby, and this guy wrote in 2006 that data is the new oil, right? But building upon that, there was another person called Michael Palmer, who later on in one of his articles said that although data is oil and it is very valuable, but if it is not refined, then it is of no use, basically. So essentially, a data science practitioner is a person who processes this raw data and converts it to valuable insights, patterns, or actions for any business or an organization. So you asked me like what do we do on a day-to-day basis? So coming to that, it's basically divided into these 4 to 5 sections, if I may say so. So the first part is data processing, and it's basically self-explanatory, but just to elaborate on that, to get data from various places where it is stored and to convert it into a format which the machine can understand. So that is essentially data processing. Then the second thing is feature engineering. So feature engineering is nothing but converting this process data into some useful information. For example, maybe your biometric information is a part of if it's a part of a data lake, but converting it into a format. Let's say if I have a column which has the heights and the weights of all the students in a college, that would be more of creating some features out of that data, for a very simple example. And then the third part is essentially training some of our algorithms, some of our data science models, which basically are the magic boxes, and which ultimately deliver, the insights or the value to the business. And ultimately, the last part would be to translate this this information or this all this data science magic into a business context, so that the business can gain value out of it. And then lastly, we basically put our models into maybe a service or an API where it can be called and used by our users. So that's everything in a nutshell. Interestingly, all these 5 tasks are not divided uniformly in a day for a data scientist. So as you can see in the pie chart on the right hand side, that data processing takes as much as 40% of the time. So let's say if you take one day, maybe from 9 a.m. to maybe like post lunch, we are basically doing data processing. And the other 30% is taken by business context. So, talking with the stakeholders, understanding what is the problem, what do we need to do, what is the ultimate metric which we want to deliver, and so on and so forth. And model training and feature engineering and development only takes about another 30%, 10% each. So there you have the breakup. So I think this is enough explanation to understand what a data scientist goes through in his or her day.
So it is actually the combination of the mathematics, analysis, and the coding skills, all everything at once.
Yep, definitely.
But people who are actually going in the IT industry, everyone is talking about the coding and coding skills. And we all know that working in the IT industry, coding skills are the important. But can we, bust this myth right now? For becoming a data scientist, mathematics is very valuable, and how much value the mathematics, have in the, career in the data scientist.
Yeah. So first of all, even to become a very good developer or a coder, you need to have good mathematical background, right? That's a given. So without maths, you cannot even become a very good software developer, because algorithms are fundamentally mathematical in nature. But specifically for data science, maths becomes even more crucial or important, because we are basically it's like statistics on steroids. So we are basically enhancing the power of statistical methods and taking some assumptions or making some build up over simple statistical techniques to make the machine learn a pattern or see a pattern within some data. So in order to so if you are a very good coder, maybe you can use some pre-built algorithms designed by others and just apply them to day-to-day tasks, right? But when you are in industry and you want to solve a business problem specific to your company, let's say you are in an organization, and definitely you would be having a problem which would be in some aspect very specific to you, right? Some aspects of the problem can be generic, but some aspects of the problem definitely would be very specific to your organization or you. So when you want to do that, when you want to solve a problem that is specific and new in a sense, you have to have a good mathematical background so that you can do your own data science, do your own analysis, and bring out solutions which are not existing elsewhere. So it is just not using what somebody else has built, but building on top of that, or making some designing some new algorithms which would definitely require data science, which would definitely require mathematical background. And just to add to that, even having a good understanding of how to use data science algorithms definitely requires a decent background of algebra and statistics, because without that you would not be able to do what is called as hyperparameter tuning. So every data science model has different levers and knobs. So just like in a machine, you have different knobs or levers which you can adjust to make the machine work according to your need, right? Similarly, a data science model has some parameters. If you change the parameters in a certain way, the model will work better according to your need. So in order to know how to change these parameters and make the model work according to you, you need to have a decent background in statistics and mathematics. So that's why maths becomes crucial for data science.
So, sir, as you talked about now recently, that it all depends on the industry also, that how much we are going to go. So, just I want to, and everyone want to understand the scope of this data science career, that how it changed according to the industry, like how it is relevant to the e-commerce industry, how it is relevant to any fintech industry, or we can say that is there a scope of data scientist in a manufacturing industry also? So,
Yeah,
how wide this career is?
Yeah, that's an interesting question. And you mentioned manufacturing industry. So I have actually done a couple of projects for manufacturing clients. So I know that manufacturing clients have a very different kind of need and in comparison to like a fintech client. So basically there are two to three things which vary based on the industry, and which make data science specific to like a given industry and different from other industries when compared within them. So what are these three things? So one of the things which come to my mind is the mathematical assumptions which we take. So in every data science model, we have certain mathematical and statistical assumptions which we take to basically apply certain concepts and solve certain problems. So these, first of all, these assumptions vary across different industries. So finance data would be having a different distribution maybe than like a variable coming from a pharma industry, right? So these statistical assumptions vary across industries. That's the first thing. The second thing is that every industry has its own kind of regulations applied to it. For example, let's say there's a media industry, right? You are creating an advertisement, and you're doing it using some AI or data science technique. Now, the kind of regulation which will be applied on you would be that you cannot publish anything which is maybe obscene or not for public consumption, right? So that's a kind of regulation you have on top of that industry. Let's say you have a banking industry or a a company. There the regulations would be very different. There you need to have each and every process within your organization fully transparent, and you need to explain what you're doing to the authorities, right? Let's say you're predicting, or you're basically classifying a loan application, uh, and saying that I will accept this loan application or reject this loan application. So later down the line, you might get an inquiry from some regulator as to why you accepted or rejected a loan application, right? So let's say you're using a data science model to classify your applications into valid or invalid, and your data science model is such that it doesn't give any information to the user as to why it rejected or accepted. That would just not work in fintech, because you need to be very transparent, and you need to have strict regulations, and answerability to regulatory authorities. So these are the different kinds of things which are applied to industry. Let's say we take the case of a pharma client. Now, everybody knows that pharma industry is directly linked to people's lives, right? If you have a data science model, let's say, and it is giving out certain predictions, but it is not telling you why it is saying something, you just cannot explain that to regulatory authorities, for example. So I did a project back in my initial days in the industry for a pharma client, where we had to explain everything which our model was predicting to basically FDA people, right? So if we are not able to explain it to the authorities, it's over. So howsoever good model you build, but if you're not able to explain it to the ultimate authority, they would allow it to be in place. But certain other industries have lesser regulations. For example, media clients. If you're not showing anything which is not good for public consumption, you're fine. Basically, you do not need to explain why your model is saying something which is as sensitive to as compared to fintech or pharma. So I hope that answers your question.
So the thing is that as we are talking about the data science career, and also one more thing is that there are few people who are actually the startup founders here, and also many of the people who talk about who joined there are the startup founders. So can data science help actually startup to create a good distribution for their consumer, and can help to enhance their business, grow their revenue, sales, and everything? And how is data science relevant to them?
Right. So it actually, if I speak very critically, it would depend on the kind of startup or kind of problem they're solving. But in a generic sense, data science can be of help to grow a business, in the sense that it can, if you have the access to the right kind of data, it can very much help you find your target audience. So let's say you collect publicly available demographic data, or you get like from a paid data source, or somewhere you get like the kind of internet consumption pattern in a city or in a geographical area, or let's say the network connectivity in a geographical area, and you are an internet based startup. Now, if you overlay internet connectivity data, mobile coverage data, and demographic data over one top of the other, and create some useful features out of that, you can get a really good sense of where would you want to target your ads, or where would you want to target your publicity marketing campaign, so that you can get maximum conversion for your product. So that's an initial case where data science can help startups find the right kind of customers. But it would definitely depend on the kind of problem a startup is trying to solve.
Because many startups have asked the question that do they have to hire the data scientist at the early stage of their startup, or they can work and they can grow business without that. So that's why I have asked this question.
Okay. In that context, I would just like to like bring you to this slide where I have mentioned different kinds of data science roles. So data science is not a monolith, right? You have different kinds of complexities or skill set within the data science domain. So maybe a startup would not want to hire, like, let's say, a managerial kind of a person or a specialist kind of a person, but they would want to hire a data analyst or data consultant or a data scientist who can give them quick, return on investment for their money. Because once you hire more specialized roles, specialized people, they would maybe need like an infrastructure already set up, or they would need like a huge data lake already in place for different kinds of obviously modeling. So maybe a startup does not have that much data to build very sophisticated algorithms on top of it. Maybe at an initial stage, you want to work with simple statistical or maybe simple modeling solutions, which would give you quick ROI with less investment. So there you would want to hire maybe a data analyst or a data consultant who can give you quick insights and where to do what. So maybe you are not looking for predictive or algorithms which try to predict for you, maybe give you some suggestions, but you're only looking for insights. So maybe you want to ask a question: where is my target audience located in India? So that kind of questions can be very well answered by data analysts or consultants. So those are the kinds of roles you are looking for instead of maybe a specialist role.
So basically, data scientist is way different from the data analyst or data consultant. Data scientist basically focus on the models, creating models, architecture, and everything.
Right. So basically, I have basically created like a scatter plot to explain that better. So on one axis, there is hands-on time with models and data, and on the y-axis, there is business understanding and communication. So basically, there are three kinds of clusters in data science roles. The first cluster is the pink one, which consists of the analyst, the ML ops engineer, the ML engineer, who would be very much hands-on, very much hands dirty with the algorithms and the data, but they would not be as deep into the business context as some of the other clusters. Now the center cluster is essentially the senior data scientists, consultants, and specialist roles, where they're doing the modeling and data science stuff, and along with that they're also doing business communication and all those business translation as well. So they are so that is the middle part is the hot part, right? That's where you all those terms, the sexiest job and all fall, because they are the guys who would take more money and would like bring maximum amount of the value, probably. So not in a very strict sense, but in a loose sense. That's what I want to say. And the third cluster would be the green one, which has the manager and the lead positions. So maybe a startup would want to hire like a couple of analysts along with some senior scientists, and like make a team of 5 people and then see what they can get out of their money with that.
Now, I want to tweak my question to the people who are actually in right now in the graduations and they want to aspire to become the data. Now, what kind of a coding skill they need to acquire, and at which extent they need to improve their coding skills to become data scientists? Because as we know that becoming data scientist is becoming an ML engineer also. So we know that R language, Python, Tableau, these all are going to be used. So how much these are useful and what they do in the data scientist side?
Right. So for a data scientist, I would say that Python has become more important than R maybe now. So back when I started, which was like around 5 years back, like R and Python were almost neck to neck. And still R is being used in some cases as far as my information goes. But Python, due to its other advantages, like it can be used as scripting language and to build applications, has basically overtaken any other language for data science and AI. And like the kind of community support Python has is just probably unmatched. I think only second to JavaScript. So Python is the language to go for data science roles. But yeah, your question is how important or how crucial is it to get to for the role. So the answer to that would be it is quite crucial. It is as crucial as mathematics or statistics. The reason being that no matter how much knowledge of the maths or the stats you have, ultimately it is the coding language or the programming language that will help you realize the value, right? So ultimately it boils down to how fast and how bug free your code is, because if your code is bug free and fast, you would be getting the insights better than or like faster than others. So it is very important to be like your give your A game to coding. But then having said that, the coding skills required are different from that required for a software developer, because the software developer needs to be very pinpointed towards optimizing their code in terms of memory and time consumption, right? But I think data scientists at first are not required to write the most optimum code at first. So I'm stressing on the word the first, because once you are getting the insights from the data, it's that time that you do not need to write like very optimal code. In some cases you might want to write, because otherwise your data systems would be at stress. But it is only when you're going to deploy your models that you actually need to write production level code. So once you're in so at the graduation level, when you are preparing for a data science role, ensure that you have a good understanding of how to use Python to do scientific calculations and write clean, working, bug-free code for analysis requirement. So I think I have suggested this to like a good number of folks. There's a course called Python for Everybody. Sorry, Programming for Everybody using Python on Coursera. That is the course through which I started my journey in Python, and I highly recommend that course, because that course basically covers most of the things required for a data science role and a grad student to start their journey in data science. So yeah.
So as we are talking about a day-to-day life of the data scientist, so on that previous question only, so if you will you want to say that how much time of the whole day you will spend on the coding, and how much time you will spend on the analytics and everything.
So it goes hand in hand, Sanjeev. So it's not that you would be coding in a separate part of the day and doing analysis at a separate part of the day, because ultimately the analysis which you are doing, you would only be able to get that analysis through writing some code. So let's say your data is stored in a database, and you want to get that data from that database to your system and plot some graphs on top of it, right? So there are 2-3 parts involved in this process. One is your SQL query, which you will write to get the data from the database. The second is your the kind of the operations which you will do on the data to make it more meaningful. And then third part is the plotting part. So the first part is the SQL. So you need to know how to write proper SQL queries so that you can fetch the data. That is the first requirement. The second part is writing code so that you can convert the raw data into whatever feature or whatever information you want to get from that data, right? And the third part would be to plot it. But the third part is probably the easiest part, because these things have already been taken care of in some libraries or packages which you would use, right? You would not be writing plotting code directly. So essentially you are doing coding, and then you're seeing the graph as an output, and then drawing your analysis or insights from that, right? So they both of them go hand in hand. Now this is a very simplistic example, but if you take a more complex example, where let's say you have to create a model and then see its output and then check whether that output is making sense or not. Now to do that, you have to basically write like a good amount of code first to solve everything bug free, get the data, train the model, get all the results, your predictions out, and then you would start doing your analysis checking that how good are the predictions, how bad are the predictions. So basically, both of these things go hand in hand. There's no separation between coding and analytics. So I would say that you should not
You have
look
to
at
make balance between both.
yeah, basically you have to have a balance, and you cannot separate them.
So about that, as we can see that data scientist is not an entry level job. So what can be the roadmap of becoming a data scientist? Or
Yeah.
it can be a entry level job for some folks.
So the entry level job is a data analyst or a data consultant, and then you move towards being a data scientist or a senior data scientist or a specialist. So that is the career path, and also the ML engineers are also there. So analyst, ML engineer, then scientist, and then specialist. Kind of that path is there. So I would say the roadmap to become a data scientist would be to first get a good grip on basic coding and basic Python programming. Once you are good enough and you can write code comfortably, then you should start working on your statistical concepts. Have a good grip of basic descriptive statistics, and all the other advanced concepts which are related to statistics and that branch of mathematics. Once you have a background, like a good enough base with statistics, start with learning the initial concepts of machine learning, and that's where you will start getting into the domain. Basically, once you start learning machine learning, there are few divisions within the topic, which is unsupervised learning, supervised learning. So all these concepts, once you start getting through, you would basically start your journey into the field. And then obviously you need to get some understanding of solving business problems using these concepts. So try to get onto, let's say, websites like Kaggle, which host data sets and allow you to basically participate or solve those data sets using ML techniques. So try to apply those learned concepts on Kaggle and open source platforms, and see how good are you in building models and explaining insights into the data. As you grow, as you practice more and more with open source data, then you can, I think if you have couple of projects on your GitHub or resume, you can get into probably an internship, or you can get into a project in your college, or maybe in your organization, which is in which people are using machine learning and data science. And then you start to gradually get the industrial experience, and then it is just like any other field, basically practice and grow. You're on mute, I guess.
Thank you, sir. We are going to actually, I'm going to move to the last question, and after that, I will start the question answer session. If you have any questions, everyone, you can also put in the chat also, so that we can, speed up this whole process. And also, you can also ask the question by unmuting yourself. So, my last question is, sir, we are right now for the last 1 month after this Twitter thing and Facebook thing and everything, we are going with the layoff season. Every company is laying off, and right now, at the same time, data scientists are right now in the very much demand. So my thing is, because for the developers, we are coming with the low code system, which is in some extent extending the job of the developers, also reducing the job of developers. So this data scientist role, is it just a kind of bubble right now? Everyone is talking about it and every company needs it, and someday it will burst and then there will be no requirement, or this data scientist role will go on for a long time.
Okay, that's an interesting question. So, and especially because you have given the scenario for the developers, and then juxtaposed it along with data science, that makes it even more interesting. I think data science is not a bubble. That's my opinion, and the reason behind this opinion is that data science in itself is a very subjective job. So when it comes to software development, there is a fair amount of objectivity to it, right? And that's why you're seeing a lot of automation happening with the software developer part. Like the biggest example probably is GitHub Copilot, which is a data science miracle. Not a miracle, but like a data science, a very fancy data science model, which basically automates how you write code. So but the data science, when it comes to machine learning and AI, we see that it is very subjective to every organization, every person who is solving a problem. Why is it that? Uh, so first of all, let me clarify that there are parts of the data science job which are also objective and which are getting automated. So there are companies like Data Robot and other platforms which are creating auto ML solutions. So what auto ML solutions are basically, you give a data set to that auto ML solution, it will train 100 models on top of that data and give you the best model, and you can directly use it according to your need. Now this is where automation is also happening in data science industry. But the thing is that howsoever sophisticated model you train for a problem, there will always be some corner cases which the model will not understand or which you will need to hand you. That is one part. Second is, even for like a model to work very nicely or to like solve your business problem, you need to feed. So you cannot feed raw data or like just dump the data into the model. As I mentioned earlier, you need to do some feature engineering. What is this feature engineering? Feature engineering is basically creating some variables or some columns in your data which have very peculiar meaning for your business problem, right? So to create those feature variables, to create those data points which give the model that information about how to take the decision, that itself becomes very subjective based on the business problem. So let me just give you a quick example of how this works. So let's say you have a grocery store just right next to your house, and you are a data scientist, and that grocery wala bhaiya knows that you are a data scientist, and one day he just asks you that, can you make a prediction model for his onion sales, so that he can optimize his inventory, right? So now you basically create 3 models and show these models to the grocery wala bhaiya. And let's say in a day that person sells around 10 kgs of onion, right? So you have model 1, 2 and 3. Now model 1 says he will sell 15 kgs, model 2 says 11 kgs, and model 3 says 9.5 kg, right? So as a data scientist, you see that okay, my error, how much is my error, right? In the first case it is 5 kg, in the second case it is 1 kg, in the third case it is 0.5 kg. Now a data scientist is very happy that, okay, model 3, I am done, cool. Now you take these models to the grocery vendor and you say that, okay, model 3 is the best, you can use it. But then the vendor tells you something very interesting. Now the vendor says that if I have an excess stock and that onion gets rotten, let's say, I will incur a cost of 40 rupees per kg. But if I have less stock, and because onion is something that everybody buys, and let's say if I don't have onion, people will also not buy other vegetables from me, because like they will buy from somewhere where they are getting everything at once, right? So I lose basically 90 rupees per kg of business. So when this information comes to you, now your analysis would change. Now you would say business loss for every model. For model 1, it is 200 rupees. For model 2 is 40, and model 3 is 45. So according to the business, the second model is the best. So there you see that, right? There is a subjectivity, correct? Now this subjectivity will change with every vendor. Right. Maybe some vendor would say, okay, no, I don't want to. It's fine if I incur 45 rupees, but I want to. I do not want to keep excess stock, right? It can be his requirement, right? So this subjectivity is very hard to automate. So because of this subjectivity, data scientists are here to stay, at least for the foreseeable future. It is not a bubble which will suddenly burst. I hope I make my case.
So the next question I am moving, one question I'm getting from Dipti, and I think that I'm talking that a lot of companies are actually promoting data science. That please take the course of data science, and data science is very important. So my question is, so many people these days promoting data science program to different stream people. As you said for data scientists, and yeah, exactly. Many people are getting call any with any stream. Are you commerce or anything? Anyone can become data scientist. So the question is that you said that having the good knowledge about statistics and computer language is necessary for becoming the data scientist. So, could a PCB stream student can do the data scientist course?
Yeah, so this is a good question. Thanks, Dipti, for like asking a very different question today. So PCB students can definitely take up data science. So in fact, the course in which I got introduced to data science was an interdisciplinary course. So in IIT Bombay, I was a part of CSRE department, which hosts which is a multidisciplinary department, and people from electrical, civil, mining, physics, all these different backgrounds come together to learn data science and how to apply that to geoinformatics field. So similarly, in the case of PCB students, yeah, it is sure that they would have to put in some efforts into developing some background for statistics. And I'm sure in at some point in time, even PCB students need statistics to do their analysis in maybe in their masters or in their PhD thesis. So they would definitely have to put some efforts into building a statistical or a statistical background. But once they have like a working knowledge of statistics, there is ample scope in for students coming from PCB streams, because we are seeing that there machine learning and data science is helping in genome sequencing and all those heavy computation applications. So there is ample scope for PCB students in those streams of science, which can really use data science and machine learning capabilities.
I think you have got your answer, Dipti. I think any stream, anyone can learn the data science and all its branches. So I think I'm getting one hand raised from Puneet. Puneet, you have any question?
Yeah, can you
can
hear
unmute
me?
yourself.
Yeah,
Yes.
I have a question. Can you please hear me? Hi,
Uh,
Anko. I'm Puneet.
Hi, Puneet.
Yeah, okay. So thank you very much for your presentation. So yes, I have seen your scatter plot in one of the slides. So you have shown that the consultant and the data scientist are both like in the intermediate level of the business and the data science roles. So may I please know how the data scientist role is different from the data consultant role?
Right. Interesting question. So it actually depends on the kind of organization you're in, right? So let's say you are in a consulting organization. There, a data science consultant would be, I think, more apt role for a data science practitioner, because in those kinds of organizations, business communication or presenting your outputs in the most business friendly manner takes slightly more precedence as compared to like only doing strictly data science stuff. But in a more product or an R&D setup, a data scientist kind of a role would be more suitable, because you're basically working for your own problems, and your stakeholders are also very in like very close connection to you. So there you need not like do a very strict kind of a business communication with them, because you are in like along with them solving a problem. It is not that they are your client and sitting outside your company and then you're explaining something to them. So that's why I just kept them in the same bucket. But at the same time, there's a slight amount of difference in the kind of communication and the kind of problem solving they do.
Okay. Does that also mean that the data scientist, like a data consultant, does not need to have a strong coding skills, or as compared to the data scientist, because he has to communicate with the business, or does he also has to like prove that or to show the coding or to show the proof like he has this problem can be solved using his idea or using his like way.
No, I don't think that they like there is no there's not a significant difference between like the kind of coding skills both
Oh.
need. So both should be like giving their A game when it comes to coding or data science stuff. But I basically the whole difference comes into play in the kind of communication you are doing. So
Oh.
in a scientist kind of a role, you're more focused on innovating and creating new data science models or architectures. Whereas in a consultant role, you're more focused towards solving business problem using the already available data science solutions at your disposal.
Mm.
But the kind of coding skills or like mathematical or statistical background is almost the same. Look, so basically there will be difference, but keeping them in the same cluster means that average uh, skill
Yeah.
required for consultant and scientist role would be around the same.
Okay. Okay.
Yeah.
Thank you very much.
Thanks. That was a very interesting question.
Yeah, actually, I am your junior, so I will connect with you later on. So I have some questions. Maybe.
Definitely.
Thank you.
Yeah. So just for like the people who are on the call, if you have any doubts or you want to reach me, you can like email me on my email ID, or you can connect me on this handle on any of the social media. So just if you just want to connect with me. Thank you.
I can put a link of this in the chat also. That will be
Yeah.
Yeah.
That would work.
Thank you so much, sir. Thank you so much for joining us. Thank you so much for agreeing to your insight have helped a lot of people. And
thank you, Sanjeet. Thanks for your invitation, and I hope the event is a roaring success. Wish you the best.
thank you so much.